In this video, we're going to use a chemical amount to find a mass. We're going to use a molar mass to get that. So this says sodium sulfate is mined from lakes and deposits along the Alberta-Saskatchewan border. Convert a reacting amount of 3.46 millimole of sodium sulfate into mass in grams. So they're specific that they want the mass to be in grams, so that's important. And we're using sodium sulfate. So they want the mass of sodium sulfate. The molar mass of sodium sulfate, which has 2 sodium ions and a sulfate ion, which has 1 sulfur and 4 oxygens, is 142.05 gram per mole. And they tell you that the number of moles of sodium sulfate is 3.46 millimole. Well, that's the same as 3.46 times 10 to the negative 3 mole. So we can use a conversion factor to find the mass of sodium sulfate because 142.05 grams of sodium sulfate equals 1 mole. So we can use that relationship between mass in grams and moles to calculate this because we already know the mole. So if I take the molar amount, 3.46 times 10 to the negative 3 mole, and I want to get mole to cancel out and be left with grams, 142.05 grams is the same as 1 mole. So my moles cancel out, and I'm going to get 0.00346 times 142.05, and that gives me 0.49, and I had 3 sig digs, 1 gram of the sodium sulfate. I can also manipulate my formula that the number of moles equals mass over molar mass. If I want to find the mass, I can solve for mass. Mass equals the number of moles times the molar mass. So the mass of sodium sulfate equals the number of mole, we said, was 3.46 times 10 to the negative 3 mole, times 142.05 gram per mole, and it'll give us the same number of mass. So there are 2 different strategies to be able to calculate that, where we've rearranged the formula or we use a conversion factor. Both of those would be acceptable in my class, and some people use the conversion factor more because it's less likely in complicated calculations to propagate errors. But if you're keeping track of your numbers, it should work out okay.